Okay, hey crew. So let's talk a little about designing an investigation. So if we're dealing with design and investigation, the main problem that most students are going to have is that they think they understand the scientific method, but the honest answer is a science teacher don't really do a very good job of explaining what it is, how it works, and what you should be doing. Because if there's one thing you should know is there is no one scientific method. There's so many different ways to solve any number of problems, and more importantly, answer some questions. That's the whole idea of science. Science means knowledge, and therefore, your investigation should be to obtain knowledge. Now, typically, in scientific terms, we're trying to find knowledge about one thing's effect on something else, okay? There's always what we call two variables in an investigation, okay? And you guys should recognize these from math. So, your x and your y. You guys know enough from math class to understand that this is your independent and this is your dependent. In other words, this guy down here always moves eternally this direction to the right, okay? We usually put time down here, okay? Because it's always moving on its own. This over here, the y, will respond in kind as time goes on, either slowly going up and up and up, or slowly going down and down and down, or maybe staying the same, or maybe going up and then down. It doesn't really matter. The x is the factor we want to see have an effect on y. Now, whether or not x does have a factor on y really depends on, the investigation. The investigation's job is to see, is there an effect? You might recognize these things called correlations from a math class. One of the things, and I'm a math teacher here, and I include myself in this, one of the things we math teachers need to do a better job of is explaining how these things relate to real life. In real life science, you need to know that this right here represents a no correlation, which you probably memorized in math class. But in scientific terms, it means that your x and your y, your two variables, do not have any kind of link. There's nothing between them that makes the two of them connected. However, if we start plotting things and we notice that there is, for example, a general trend, you might recognize that word trend from trend line. So sometimes the data shows a trend that as your x increases, so does your y. You get this positive slope. We call this a positive correlation, right? And of course, negative would be the opposite where we're going down here, okay? Now, whatever it is, what you're looking for is a connection between these two things. There either is a connection or there is not a connection. If there is a connection, it can be positive, it can be negative. But a zero connection or whatever, those are the things that that we're also looking for here. So we're just looking for how x's and y's interact and relate. That's the idea of an investigation. X and y, two variables, okay? So if we're talking about two variables in an investigation, we want to see how one thing influences another. So I don't have real stuff here, but I feel like this is going to do a good enough job because this is usually what I use in my mind to remember things. So let me flip. All right, so if we're looking right here, you should see I have 1, 2, 3 glasses, okay? Imagine I'm going to put seeds in each of these along with some dirt, okay? We're just doing a little imagination game here. So we got seeds, we got dirt in all three of these. Now, we have, again, like I said, two variables, right? So what I'm going to investigate is how water affects plant growth. You should know that from some basic life that water helps plants grow, right? So there should be a positive correlation, right? As the amount of water goes up, the amount of plant growth goes up, at least to a certain point, and then it flattens and descends. But you get the idea, right? General positive trend here. Okay, so to that end, what I want to do is I want to design an investigation, okay? So what I need to do is reduce my investigation of water's effect on plant growth, right, to two variables. All right, I want to see how water makes plants grow. Therefore, my two variables are water and plants growing because the water can vary, all right, and then the plant can vary. They can change, right? Change in their growth level or change the amount I'm adding. So they're my two variables. Now, the two variables, I like the terms, instead of x and y or dependent, independent, I like manipulated and responding. You manipulate one to affect the other. So in terms of our two variables, water and plant growth, water is going to make the plant grow. Plant growth is not going to make water. Okay, so the manipulated variable, the one that I am physically changing, will be the water. I'm changing the amount of water in these cups. Okay, so let's say I put a seed in each along with some dirt. Okay, now I'm going to add my manipulated variable here. So add, oh gosh, there's water everywhere. Copious amounts here. All right, I'm going to add a little bit over here. And then I'm going to add nothing to this guy. So if we take a look a little bit lower, you'll see I got my 3 cups, left, middle, and right. Now, of these 3, right, you'll notice that I'm manipulating the water level, right? So that's my manipulated, my independent, okay? And the responding will be the plant growth after that. Now, I'm going to get data later that will say that this one is going to do better because it's got more water, okay? And this one will do a little bit worse. And you might not get anything in this. And that's kind of an interesting point. Why did I not put any water in this? Well, what you're going to want to have is what's called a control. Some sample where there is no treatment. A control literally means no treatment. You're not giving it the manipulated variable at all. So in this case, I'm manipulating the amount of water, so I'm not going to put any water in. And we're going to see if the other factors like the wind or the sunlight or the heat, we're going to see if any of those factors make the plant grow more. Okay, if they don't, that must be the water that caused it. So this is my way of eliminating all other variables by controlling for them, having something with no water being added to it to see if water is in fact the real cause of this, okay? Now, I'm making a hypothesis here. My hypothesis is that a directional hypothesis. In other words, if the amount of water goes up, plant growth goes up. It's got a direction to it, okay? Right? Either positive or negative. I can have a non-directional hypothesis where if I add water to it, then there will be a change. I don't say if it's going to go down. I don't say if it's going to go up. It's non-directional. All right, and then I have the zero or null hypothesis. And the null hypothesis, what I'm saying is there's going to be no effect whatsoever. Water will have no effect. Now, we know that's not true, right? Because when I get more of an effect in this one, I'm going to know that water does indeed have an effect. The null hypothesis is just to see if there's anything going on whatsoever. By predicting nothing happening, right? When something does happen, you know it happened for a reason. Okay, the null hypothesis is very good for just telling if something is affecting at all. All right, it doesn't tell you if it's getting better or worse. It's there to tell you if there is any kind of change whatsoever. And so you have 3 types of hypotheses, and they're all very important. Now, the big idea I also want you to get with this is when we're setting up our experiment is keeping things constant. You have a control with no treatment, right? No water, no manipulated variable, the control. Constants are things kept in constant. So all 3 of these get the same amount of light. They get the same amount of heat. They get the same amount of soil, the same amount of oxygen. You name it. Everything else has to be kept constant or the same. You know that from math class. Constants are numbers that don't change. Variables are numbers that do change. And so constants are things being kept the same. Okay, so manipulated, I manipulated the water, right? Responding, the plant growth, because it responds to the manipulated. The control, where I'm not adding any water, no treatment whatsoever. These 2 receive treatment. They receive a treatment of water. This receives no treatment, okay? Now, constants, things that I'm keeping the same between all of them. It's easy to get constants and control mixed up, but it's important you know this. They're going to look for a control in your experiment. They're going to look for different levels of the variable, okay? A lot, a little. They're also going to look for repeatability. So in other words, I would not do this one time. I would do it anywhere from 3 to 5 times, just to be sure. And then, as always make sure you're writing down the fact that you're recording data. That's another big one here, okay? So whatever data you do get, make sure that you record it. I'm getting my head in the way there. Make sure that you're finding a means and writing about a means to record it. So if I can, one more time, 2 variables in each experiment, right? One affecting the other. Manipulated affecting the responding, all right? You're trying to set up an experiment where you're manipulating it, right? Where one gets a little bit of treatment, one gets a lot. And then you have one with no treatment. That's your control, okay? What else here? Keeping things constant, making sure you make a note of that. Everything else is kept constant. Dirt, sunlight, all that other stuff. Let me see. You're going to want to repeat the experiment multiple times. Repeatability is very important. Sorry, the battery's running low. That's why I'm talking really fast. And anything else? Oh, hypothesis-wise, okay? Make a hypothesis. They like the if-then statement, right? If I add water, then the plant will grow. Directional hypothesis. Adding water makes plant grow, right? If I add water, the amount of plant growth will go down. That's a hypothesis too. It's just a negative directional, okay? And then you have the non-directional. If I add water, there will be a change in plant growth. It doesn't tell a direction, it just tells something's going on. And the null hypothesis is if I add water, nothing's going to happen. And then when something does happen, right, inevitably, I can say that water does have an effect on plant growth because it's just a prove things true or false kind of situation. The null hypothesis is good for that. And make sure you collect the data and talk about how you record it and tables or charts, maybe make a graph that kind of thing. And that's how you would set up your design investigation, okay? But make sure you know what a control is. Control receives no treatment, right? So if we look at my water example, control, no treatment, a little bit of treatment, a lot of bit of treatment, okay? Those are the ins and outs of design and investigation. I hope that helped. If this sucked, which I understand it could, just send me an email, text, berating me about it, and I will go in and fix it and do it again. Anyways, love y'all. Take care. And remember, be ready for Monday.